Greetings and welcome everybody to today's panel session, The Pitfalls of Edge Security in the Physical and Virtual Worlds. My name is Brian Partridge. I'm a research director for 451 Research, a division of S&P Global Market Intelligence. My job is to lead our digital infrastructure, IoT, and telecom research practices. So the topic of edge infrastructure and security is center target for my firm and my teams. Just a couple bits of housekeeping before we get started. We encourage you to submit any questions that pop to mind during our discussion. We've allocated plenty of time to take Q&A. If we do happen to run out of time, we'll be sure to follow up with a personal note. Before I set a bit of context with the market view and some data points, I'd like to ask each of our panelists here to introduce themselves, their roles, and their orientation to today's session topic of edge security. So let's start with our host, Raghu.
Hi, thanks, Brian. Hi, guys. I'm Raghu Vate. I run product and customer success at Zedida. Been with Zedida for 4+ years. Kangwan.
All right. Good morning, good afternoon, everyone. Kangwan. I run solution architecture for VMware Edge Compute. Actually, my background is in networking and security. I spent 10 years at Cisco and then FireEye, which is actually where I start to see a lot of crazy stuff of how an organization can be breached and hacked. And then later on, I came and joined VMware. Look forward to a good discussion with the panel and you guys today.
Excellent.
I think it's my turn. I am Francisco Lozano. I am responsible for the IoT department in PV Hardware, which is a major manufacturer of photovoltaic trackers. And my job consists mainly in making sure all the devices, all the fleet are available and running the software they are intended to. And also they must be safe, of course. So that's why I am here today.
Thanks, Francisco, and welcome to all the panelists. So to set the stage for the discussion today, I'm going to start with just a bit of preamble of what my team's been seeing in the market around edge infrastructure and services, and I'll review some survey results collected amongst your peers in some work that we did over last summer. But to start off here, it's clear that the modern OT IT environment is just swarming with use cases that can benefit from edge computing. This is not a hammer and search of nails at this point. And these include apps and services designed to enhance customer experience, improve workforce efficiency, enhance operational efficiency of plant and equipment, optimize supply chains, amongst many, many others. And of course, the volume and the impact of the use cases not only reflect what is a highly diverse market, but one that is increasingly positioned these edge locations and this infrastructure as a key contributor to overall success. So we're all seeing this and feeling this in the marketplace. And as more and more of this business critical data ends up landing on edge servers, with the expectancy to provide all the value of that edge infrastructure in terms of real-time insights, reduced latency, the ability to support data sovereignty requirements, it also points to why organizations are increasingly concerned about the security and privacy attributes of that edge computing infrastructure. And as I think we probably all know, there are very unique aspects of those edge environments, including limited space, proximity to customers. They don't always accommodate standard IT and OT security processes, the technology that's deployed in secure, centralized and core data centers. So in order to sort of uncover some of these dynamics, what we've done is we've done some OT IT decision maker research. Last year, we talked to just over 300 of these folks, and we really just wanted to double click on how we were thinking about their physical setup, security, getting to the infrastructure, and these sorts of things. So when we ask about technical challenges, security always and without fail lands at the top. So security and data privacy is the #1 most identified technical challenge encountered when deploying and managing edge infrastructure. And the color around that is it's often that these edge locations are bereft of dedicated IT staff. This, of course, exacerbates the challenge. And if the IT teams can't physically get to edge servers at any given time due to either geo proximity or lack of credentials or any other issues, then the security issues there can quickly emerge and amplify, especially if something fails, something needs to be replaced, physical config updated. So again, just to double click a bit on this and give you some data points of what we found, 39% of the organizations we talked to, so 39% of that 300 can get to that infrastructure, those edge locations and those servers daily, but the majority can only access them monthly. And a small but still material amount, about 10%, can only get to that infrastructure every 6 months. And then when we look at the physical setup of this and security environments of these setups, about 50% are deployed in what is described as secure IT racks and enclosures. However, 28% of the surveys that the respondents are deploying infrastructure in an open office environment, for instance, mounted on a wall, situated under a desk, under a table, on a counter. And about a quarter are keeping that equipment in unsecured IT racks and enclosures, openly accessible. And obviously, this can become problematic and create physical security risks. And when we ask about the infrastructure itself, so what's required in edge servers, again, edge security and encryption comes out as the #1 most important feature of the edge server capability, followed by things like automated deployment and resourcing, provisioning, and flexible CPU options, and small physical footprint attributes. When we ask about what features need improvement, again, most commonly identified security encryption. So we get the point here that security encryption is top of mind, and the actual physical dimensions and architectures exacerbate some of the challenges around those environments. If anyone's interested in getting access to the surveys I'm talking about here, just please drop me a line. I'll be happy to send across a summary view. Okay, so with that behind us, let's dive into our panel discussion. A quick reminder to our audience to submit any questions that you might have. I will be pausing from time to time to take a look to see what's come in. But to get us started, I want to ask everyone to weigh in. And the first question here is it even possible to ensure adequate security at the edge? And what are the high-level considerations and trade-offs to think about? And I'll start with you, Raghu.
Thanks, Brian. It's a very interesting question, right? The question about whether it is possible to secure the edge, the answer is a definite yes. It is possible to secure the edge. Now, the question is not about whether it is possible or not. It is it easy enough to actually implement it? Is it foolproof enough that you don't need an expert to implement security at the edge? One of the, there are a lot of challenges at the edge, but one of the challenges that is very different from cloud or data center or other environments is who is actually operating these edge environments, and who are the people who are actually implementing that. And this is where your weak links in the whole chain, and also the ease of use comes into picture. And those are the things that are very important. If you have a system which can be secure by nature, by design, but if you add on that a couple of layers, the first layer being making it very, very easy to implement it and be able to enforce that security. And the second thing is it should be also be very easy to monitor and have exception cases so that you don't lock down everything in the edge and lock yourself out of the whole thing. We have seen that happen multiple times over, right? And that's one of the main things that when Zedida started out thinking about how do you secure edge, these are the principles that we put in place. The first thing you need to do is make it secure by design, again, right from the hardware. Every single thing that you were talking about in terms of your survey, in terms of what is the nature of this hardware that gets deployed, what is the place that it gets deployed, who operates it, what is the security posture that is expected out of it. All of these things need to be taken into consideration when designing the security around and designing the security posture, right? But that's just not enough. And then you have to go back and design a system where implementing this security that is or enforcing the security that has been designed by a central organization should be easy. And then add to the layer, how do I monitor these things? And once you monitor every aspect of this security apparatus that you have built in, that is when you can actually do edge security properly, fully, and be able to be confident that you are not going to depend on your security scheme on somebody who might or might not appreciate the full breadth of security that is being put in place, right? And that is very, very important.
Francisco, how does that resonate with you?
Yeah, well, I totally agree with Raghu. I think the thing in this topic is to have a good layered security policy at the end of the day, because we have in PV plants, you have good fences, you got restricted access, and you have enclosures for your devices. You have anti-tampering devices also. But when you have access to the final edge device, you need to have hardened ports and everything you need to make the device safe by itself, because you are not free of having someone in the plant. Or speaking of what's my business at the end of the day, you are not free of having someone that it's not intended to be there. And well, edges are, what's the edge? You have many different scenarios that can be possible. We have the lack of having these fences and everything I told about, but in other cases you don't have those things, and you have to be safe anyways.
Sure. Kangwon, anything to add?
Yeah, I mean, I think maybe the interesting question will be, what is an edge, right? Because what about an edge can be even in a car. And I think you listen to Sanjay Upal, right? Actually, my GM, we are talking about putting an edge inside a car, right? An edge could be your supplier network, right? Something that is totally outside of your control. But now the question is, can you ensure adequate security at the edge? I totally agree with Raghu and Francisco, right? But does it mean that you're not going to get breached? It's actually no, right? Because that's one thing that I learned. I mean, when I was at FireEye, is we always tell everyone is always assume that you're going to get breached at some point, right? Because depending on the sophistication of the bad guys, if you're dealing with the nation state, they're going to take some time, but at some point, they're going to find a way to get in. But it is equally important not only to secure an edge, but be able to detect it quickly when the breach happens, because the longer the bad guys stay in your network, the more damage that it is going to cause.
No doubt.
And there are multiple ways to do it, right? One is, like we actually learned when we basically start having the branch offices, right, connecting directly to the internet, because in the old days, the traffic always get backhauled to the data center. So that way you can apply security policy before it gets out. But now everyone is talking about distributed perimeter, like using secure access service edge, which is now you maybe using like cloud services. But in the end, what they're trying to do is to centralize the policy enforcement, so that way you can have the consistencies, the the enforcement that can be applied not only to 10 locations, but hundreds of thousands or tens of thousands when you talk about remote worker. So just keep in mind that the edge is very distributed, right? So not only you have to scale it, you have to be able to detect when something has gone wrong.
Got it.
Completely agree. Monitoring and auditing and completely taking a inventory of like your security posture all the time and in real time, and being able to relay back anytime when something is not the preventive action of that, preventive portion of that is very, very important. But Kangwon, completely agree with you that as soon as something is detected, you should be able to quarantine that that area, right? Whether that area is one small device or like a full supply chain, any of those things, and that's very important.
Right, and don't forget to patch. And I know the OT team sometimes doesn't like it, right? Because in some cases we went to certain factory and we walk around, we still see pretty old system, right? And no one like to patch those systems, or may not even be available anymore. But hopefully, like with the right solution, like what VMware is trying to do, and with CData and you guys is, we hopefully can make patching a little bit lower the risk of patching the system, because be able to revert back when something has gone wrong.
Exactly.
Good deal. Just a reminder to keep those questions coming in from the audience. I've seen a couple. One here, I'll throw to you, Raghu. If an operational and deployed edge device gets physically stolen, is it still secured? And I guess that would go for, you know, in the data environment.
Definitely. So it is one of those things where what I talked about, it has to be done by design, right? One way you can prevent theft is by having physical security. But the problem of physical security preventing theft goes away when you're talking about edge, right? Like where, like Francisco was saying, like he has things where like there are secured fences, but then there are other assets that are not in the secured fences. So again, you go back to the layered approach, and now the layered approach has to go all the way down to the silicon. If you have ports that are exposed, so it is not about just theft of a physical hardware, theft of the IP inside the hardware too, right? So if you want to like, if you steal something, then you need to first of all figure out what is worth protecting inside that device, okay? So for example, if you are running EOS on the device, I don't really care about like protecting EOS on the device because those bits are available out in the open on GitHub, right? I can just go and like download it. No one is going there to like protect or steal the EOS bits. What they're there is to steal the application bits, and that is the IP that you have to protect. And to protect that, like you need to be able to like protect the ports, access, attack vectors, first of all, physical attack vectors. Then you need to be able to protect the actual applications themselves and have the volumes encrypted. And also encrypt it in such a way that like it is almost impossible to like decrypt those volumes unless like a handshake happens with an external entity. In this case, the external entity would be Zedida. And once, if so, for example, even if you are going to steal the box or a device out in the field, the worst thing that should happen is like the person like wiping that whole box and selling it on eBay or somewhere else, right? That's the worst case scenario. Anything else that happens on that same device is a breach of trust, a breach of IP, everything else. So the layer should be, don't let anyone get into the box. No username passwords to get into the box. No username passwords to get into any of the IO. Now, on top of that, every single aspect of the user data should be encrypted. And in Zedida's case, what we do is like we actually make sure that that encrypted data can only be decrypted by when the device is authorized to connect to the cloud. And then once it is connected to the cloud, only then will you open up or unseal the keys that are sealed behind the TPM. And by proving that like you cannot actually steal the physical device and actually get to the data, then you first of all take the motivation out of stealing the device. But then you always have these thefts, right? Like you cannot prevent thefts. If people are stealing things for metal, there is nothing you can do. But if people are stealing things for IP, then that is where the encryption portion comes into picture. Now, the second thing is I go back to my original point. It's not just enough to say, hey, you can encrypt something, right? It has to be encrypted by default, because the person who is going to be deploying these things out in the field shouldn't have to have that responsibility to encrypt their volumes or make sure that they work on all of those things. And on top of that, you also have to make sure that the device identity itself is preserved. So what Zedida does is like we make sure that every device that is out in the field is measured boot. So we make sure that every single thing, right from the bootloader all the way to EOS and further, is measured. And when a device boots up, we are going to compare those measured boots with another set of template that is factory defined or like the admin defined. And only when all these parameters or the PCR values match, we then open up these vaults that will then open up the application, right? So now if I just walk away with a device, then it's not going to help me get into any of these things. There is the monitoring portion of it. There is the enforcement portion of it, and the enforcement that cannot and should not be left to the hands of the people who are actually operating it, but as a centralized policy, like what Kangwan was talking about earlier, where you enforce the policy centrally and then like it gets distributed, and like on the distributed edge, every device now is enforcing that security posture. Yeah.
Got it. Hey, so speaking of theft, heard through the grapevine that PV Hardware experienced a stolen device issue. Francisco, can you take us through what happened there, and what'd you do about it?
Well, as Raghu said, you don't have fences all the way around. We have sometimes we have to deliver devices to the field because we manufacture the structures and also the devices that commanded the structures, and they go by plane or by train or whatever transport to the customer. But sometimes you have to replace a device on field, and then you give the new device to a technician that goes to the plant and then makes the swap physically. And one of those in one of those occasions, we had a technician who was robbed. A couple of devices were stealed from him, and we were calm because we have if the device is working, you have connections encrypted, and you have safe connections going to and from the device, and you're okay with that. If the device itself is at rest, we also have encryption inside the device, but we rely on Zedida's encryption of the disk to take care of the safety of the device once it's not connected to anything. If you have a device which is not connected to anything, it's pretty much a brick without connecting to the Zedida platform. So that's the story of what happened in.
Did you figure out what they wanted with the equipment? Was it just an opportunistic grab, or did they actually have intention to use it?
I think it's one of the eBay dealers Raghu mentioned. Not much of that. We immediately deleted the devices from the platform for them to not to be able to communicate or open the vault of the device, and we were okay with that. No, nothing happened.
And one of the things, Brian and Francisco, one of the things we keep hearing over and over again from a lot of our customers, and hopefully, Francisco, it's the same for you too, is that usually they actually put in a lot of process in place to make sure that the devices are not stolen. And if the devices are stolen, there is nothing, the IP is not stolen. And these processes can become very expensive when you look at the total cost of ownership, right? Because now you have to make sure that these things are sealed right at the beginning, or some of them do not even deploy applications on these devices when they are sent out, because they want to first make sure that they are in a real good position before they deploy applications, and which means that you have to deploy applications out in the field. All of these things add up the cost. And we have some calculations that were done by a few of our customers, which said that, like, okay, it's the process that they put in just to deploy the application, and the number of people and the time they spend is almost equivalent to the cost of the device. And one of the reasons why they really love the solution that Zedida is providing is, like, we take that out of the picture. We take that out of the picture in terms of, like, okay, you don't have to do this. And it's not just about saying, like, hey, trust me, you don't have to do this, right? We can actually prove that, like, even if somebody takes the device out, it is not going to affect you, and the IP is still safe. And Francisco, if I may, is this one of those experiences from you from an operational perspective, right? I'm sure a theft of a device is, like, very, very important, and, like, it's very high visible thing in your organization. So did you go through that same experience with Zedida, where you were not worried, but, like, you were also, like, not worried about what is the next thing that you have to do and the next steps? Okay, it's just a loss of an asset, and now you're thinking about, like, how do I go find it back on the eBay, or, like, it's X amount of dollars lost versus, okay, now I have to go and, like, look at the IP of that and, like, figure out how do I save that. Is that your experience too?
Well, our experience is we put in place some hardening inside the device. Of course, we do protect the virtual machine by ourselves. We do an effort to keep the things safe. But for us, it's also peace of mind to have the encryption in the whole disk, because if you put if you are not a security expert and you try to build a process to secure your device or your content, you never know if you are doing 100% you need to do to protect the device. And in that case, we rely on Zedida and the encryption and the thing that the device is bricked if not connected to the platform. That's peace of mind for us.
Raghu, I'm seeing one come in from the audience. Maybe we can knock this out here because it's apropos what we're just talking about. So the question is about how to use TPM to encrypt the data. Is the disk encrypted, partitions, VM disk? Is it required to have internet connectivity for the device to boot? Can we handle that?
Oh yeah, definitely. Again, like it's a great question, by the way. I can't see the chat and who asked it, but, like, it's a great question because it goes into the fact of operational realities versus the aspirations of a security expert sitting somewhere, right? So the first part of that question is how do we encrypt? So I'm not going to take the whole time here, but the basically at a very high level, a TPM is used for what we do is, like, we generate the certs and the keys, and the private key is sealed behind the TPM. And then the PCR values are measured every time the device boots up, and we make sure that, like, none of the PCR values are broken or, like, are deviating from whatever is the expected values. And then at that point, then we unseal the TPM, and the keys that are needed, or the keys that are needed to open up other keys that are needed to open up the vaults are unsealed. So that is how again, I do apologize. I'm going very, very high level. I don't want to take up the whole session talking about that, but that is at a very high level, right? Now, that opens up another really important operational issue that, hey, I have this device out in the field, but if that device doesn't connect to my cloud, does it mean like I cannot use my applications that are there? Because the connectivity to the cloud is not guaranteed, right? Like you might be in an air-gapped environment, your WAN is out, like it's raining outside. All of these things are realities. Now, in those cases, what we do is like we have workflows where you can, by policy, say that even if the device is not connected to the cloud, I want you to open it up, not make any further configuration changes, but it also comes with the advantages of layers. It's only one of those layers you're opening up so that the applications start booting up and the whole service is not affected. And then after that, you also make sure that the PCR values and the measured boot is fully, the integrity of the system is not compromised. And you can, by policy, set that like, okay, I want this behavior to be only available for 1 day. You can say like, I want this behavior to be available for 10 days or like a month. That's one way of solving the operational issues. The second way of solving the operational issues is by something we have come up with, which is a local operator console. It's not the same thing as a cloud connected piece, but it is a case where you can have your cake and eat it too. So, and if anyone who is interested in that side of the technology, I'd be more than happy to have a chat after the meeting. But those are workflows that are very, very real. And we have solved those workflows in a few ways, because you cannot even solve them in one way because everyone has a different set of priorities and requirements. So if you need to have that flexibility.
Got it. Kangwa, did you want to chime in on that one?
About TPM?
Yeah.
No, I mean, like, I think it's a pretty intelligent way, right? The way that I mean, E4S and CData actually does it. But you're right. I mean, TPM is a well-known technology, right? That
yeah.
So basically, the key never leaves the hardware, and so you're never going to be able to know what that key is unless you crack inside the chip and be able to look at the binary. But
so Kangwa, let's stay with you.
Way to do it. Yeah.
I love this thread of sort of real life examples. And I was wondering, you know, there's been a few highly publicized breaches over the past couple of years. Wondering for the audience, could you maybe pick out an example and just maybe talk us through what happened and how it might have been prevented?
For me, right? I guess.
Anybody, Raul, you want to take that one?
Yeah. Go ahead.
Go ahead, Raghu.
So I can think of one, and it's one of those breaches. Again, going back, I'm trying to tie this back to our discussion here, right? Breaches can be, breaches are like what Kangwan was talking about. Breaches are a reality of life nowadays, right? Like it is always a catch-up game, and you have various different levels of breaches. If people are hacking in by looking at the vulnerabilities, and when nation states are involved, it's very hard to keep up with the amount of effort that is going on from the other side. So one of the things that one example I wanted to come out with is like a year back, or I would say actually if sometime back, there was an incident that happened right after the OpenSSL buffer overflow issues. There were two vulnerabilities that came out, and it was a pretty big deal. It was high severity and everything, right? But there was another one that came out after that, which was again an OpenSSL breach, and they were this time what they did is the breach was, or the vulnerability was in the way how you would process the general names, and if instead of X509, if you can use X400, then there was a vulnerability that was there where you can actually look at the memory on the system. and you can look at any region in the memory, which means that like you can get to the username passwords, you can get to the information that is not that can be used further to infiltrate the whole system, right? So this is something that came out. Now, the experience that we had with this vulnerability is something that is definitely worth mentioning, because what happened at the time is like, because Eve is open source, and this is the power of the open source, right? Because Eve is open source, we were informed of the breach or the vulnerability even before a CVE was released. I think Joe Pearson, who is like the vice chair of the TAC and Open Horizon TSC, he informed us, and I remember the thread that went around too, like, hey, this is a vulnerability that got introduced. I think like there are a lot of people in the LF-Edge project that will be affected by this. Let's get on it. And it was almost on an hourly basis, right? Like I still remember, because this is where a vulnerability was found. We were given enough time to like address the vulnerability. We did all our inventory, made sure like there were a lot of places where this vulnerability does not apply to it. There were 1 or 2 places where it applied, and we were ready for it by the time CVE came in. By the time the CVE was announced, we actually already were talking to our customers saying that, okay, this is something that we know that is happening. And these are the steps that we are taking to fix it. This is only the exposure, and these are the patches. And again, going back to Kangwan's, it's most important thing is to roll out the patches and make it very, very easy for our customers to consume those patches, right? So this whole experience is like the power of the open source and figuring out that the vulnerabilities are normal, right? Like it's a way of life nowadays. Like these things happen. We are the people who write code, and I know like none of us are perfect. So these things happen. But the point of what do you do? How do you react? How much time do you have? All of these things become very, very important. And if you have a very large community, in our case, we are backed by LF and LF-Edge. And if you have a large community, then you get notified early. You have more time to fix it, and most importantly, you have time to like go back to your end users and tell them that like, hey, we are on that. It's a matter of fixing it, but it's also a matter of giving that confidence and the peace of mind to our end users that like this is being taken care by people who know what to do.
Good stuff.
Yeah, I have one more example of you guys. So actually, I was at ARC forum a couple of weeks ago, right? And I think this was a gentleman from CSAR, which is Cyber and Infra Security Agency, right? That's part of Department of Homeland Security. And one of the breach that was talked about there was the Colonial Pipeline, right? Because we have been talking a lot about, hey, OT and IT security and how do we secure OT, but the interesting part about that breach was it was the IT side that actually was breached. And it was such a simple mistake that because they did not have the multi-factor authentication, it ended up actually shutting down or had to shut down the pipeline. And I mean, we all felt the pain, right? Even though I'm here in the West Coast and the gas price went through the roof. And then the bad guy who actually breached the Colonial Pipeline did not even intend to bring down the pipeline, right? But they just want the money. But simple things like protecting the password, and actually, if you will properly think about putting in the right architecture with backup system in place and be able to revert back to either a snapshot or a clean copy of the software, I mean, this thing could have been easily recovered, right? Versus actually causing us all the pain for a very, very long time. So the takeaway actually for me is back up the system, right? Or have a way to do that and make sure that it's not just about, hey, I'm having an air gap network and forget that the IT and OT are becoming a lot more connected nowadays, and we need to make sure that to protect both sides.
Gentlemen, just to give a time check, we've got about 5 minutes to go here. It's been a great conversation. It's moved fast. Please keep the questions coming in from the audience. I see there's more there than we'll be able to get to, but keep them coming in. We'll make sure that we follow up with you directly for anything we don't get to. I want to ask one back to Francisco, though, and this one is about generally internal threats. Employees, contractors might have access to those systems, and they may have bad intentions. They may just be people that have made simple mistakes in configurations. How do you think about that level of threat, Francisco? What do you do to monitor for it?
Yes. Well, the thing that is, you have to put in place some kind of a compartment to have every user accessing only the things he has to access to, and not only accessing or not, but with the level of access he needs for accomplishing the task. For us, directly contractors are not allowed to access any asset. We open some interfaces, industrial interfaces, such as OPC UA or things like that, for them to consume data. So we have to take care mostly of the employees, and making everything single signed on with the Active Directory in the company is for us a really big deal, because it makes safer. If someone leaves the company, it's only one click away of losing all the access permissions. So I think it's that's the way it should be approached, and of course making audits and monitoring of every asset in the field, and logging is the key.
Got it. Hey, Raghu, let's take another one quickly, if we can, from the audience here. And it seems like a straightforward question. It's, how do you keep stolen devices from connecting back to the data and then decrypting the volumes? Is that an easy one to answer?
Yeah, there is. And again, it's based on a policy, right? Like one of the things is that if a stolen device, if you don't know, I mean, there are two cases. One is like you don't know that a device is stolen. And the second case is like, you know that the device is stolen and you want to prevent it. So having a device, knowing that a device is stolen is very easy. Then at that point, like you just have to like make sure that it is deactivated. You don't have to actually like wipe everything, because like there are a lot of false positives too, right? That's also a reality of life. Okay, so now you can just deactivate the whole device, and then that, which means that like it goes back into that state of like, okay, nothing can be like removed out of that. IP is safe. Now, if you don't know that a device is stolen, that is where the monitoring and everything comes into picture. Because what would happen now? You have to take a step back and see like how would you address that scenario? One, the person who has stolen the device or like has access to the physical device can get into your applications, or it can get into the host through an IO. So what we do is like you can, by policy, shut off all the IO except for the things that are going into the application. And for the application, you can now shut off all access to the application except for going into the proper channels, only the services that are open. And this is not when something happens, right? This is the default behavior. Every single device out in the field follows this same behavior. And one other thing that I just want to add, which also touches what Francisco was talking about, is like another thing that is really, really important out in the edge is like remote access. you need to be able to like actually log into your applications while the device is out there, right? And I have worked in places where like remote access was always considered a secondary aspect, an afterthought. Okay, I'm going to secure all of it, and now you think about, okay, I secured, I put on all those fences, but how do I get now into it? So you're breaking the security posture that you have just enforced. So what we did at Zedida is like made remote access a first-class citizen, and it is built into the system. Okay, right from the beginning, that like, okay, remote access is necessary, and how do you now protect, assuming that the remote access is necessary? And now we have like a second version of it, which is hopefully a lot more powerful than the first version that we had. But that is also a very important thing.
Wonderful. Guys, we've run out of time almost. I do want to get in 30 seconds or less a key takeaway, a parting thought, if you will, for our audience here to take away from this discussion. And I see that there are questions that we didn't get to, and we'll be sure to create follow-up events for those. But Francisco, if we could start with you, what is some parting wisdom, some pearls of wisdom from you?
I think, as Raghu said, everything has to be secured by default. No, don't think you are in the best scenario always. You have to prepare for the worst one all the time by design, and having everything traced, every device, your fleet have to be traced and monitored every moment.
Kangwon?
Yeah, for me, I think one thing to keep in mind is the weakest link is typically people, right? So I think we can have the best infrastructure and security in the world, but in the end, we have to make sure that everyone is trained and how to use those technologies and follow the process.
Final word from Raghu?
I'm completely agree with both Kangwon and Francisco. It has to be, you have to like take care of the weakest link, and unfortunately the weakest link in this whole scheme are the people. When you have when you have the toolkit that takes people out of the picture, or like minimizes the effect of them, or make sure that like you give all the ammunition to the processes, and like reduce the amount of damage that the weakest link can do to the whole scheme, that is what it is. And what that means is like you have to be secure by design, secure by default, and make sure the enforcement happens automatically, and also make sure that like operationally, like you are going to give enough flexibility to people to operate, and then take that into consideration while doing your security assessments, while creating the security postures and designing the security around your whole system, right? Start from the people all the way to the silicon, and that is the only way you can secure the edge.
Good stuff. Thank you. Thank you to my fellow panelists and speakers. Thank you to the audience for spending some time with us today and your questions. Please join us for the next session with Nathan Pettis, President of Process Systems and Solutions at Emerson. You can find the link to the session within the agenda on the general session section. Enjoy the event and have a great rest of your day.